linear relationships. I did record that, yeah. Great. Linear relationships. So, chapter 5. Probably one of the worst sections completed by students. So most students do relatively well in algebra, do relatively well in financial maths, probably accept some of those confusing questions where you have to multiply or divide depending on the style of question. But they're relatively very well done. Measurement, nutrition and stuff, fairly well done. Area, very well done. Statistics and probability, bits and pieces, poorly done, relatively okay. But linear, fairly poorly done across the board. So hopefully we can get through this pretty well. You should stop me if you are confused about something. It's pretty short. If you can see, it's only one little bit of 11 pages or so, or 9 pages really, of working. So not too complicated, but really important because it's probably the chapter that you can differentiate yourselves compared to your peers. So chapter 5, and I'm saving all of these, as you can probably see. So in that way, when you guys need to study for your prelims, I can send you this whole booklet, which has got all our solutions, and you can just go back and watch the videos, and everything will be there, which is nice. Chapter 5. Okay. So, straight line graphs. Complete each table of values and then graph the equation on the number plane. Well, you'll have a table of values, as you can see, x and y. X is 0, 1, 2, and 3. And it says the equation is y equals to x take away 1. You can see that x equals 0. So y should equal to 0 take away 1, which is negative 1. When x is 1, you're going to get obviously y is equal to 1 take away 1, which is 0. When x is 2, you get y equals 2 take away 1, which is 1. And obviously you can see it's going up by 1. So we know the next one's going to be 2. We'll do C. So when x equals 0, you're going to sub in 0 into here. So it will look like this. Y is equal to 2 times 0 plus 2, which is obviously 2. The next one becomes 2 times 1 plus 2. 2 times 1 is 2. 2 plus 2 is 4. Next one will be 2 times 2 plus 2, which is obviously 4 plus 2 is 6. Last one's going to be 8. Any questions up to that stage? No. Fairly easy, completing the table of values. Then, from that, you need to graph the equation. Okay, so let's graph this one first. So y equals x take away 1. Well, we know that when x is 0, y is negative 1. When x is 0, y is negative 1. Somewhere there. I'm just going to zoom in a little bit. Okay. When x is 1, y is 0. When x is 1, y is 0. So right there. When x is 2, y is 1. X is 2, y is 1. And pretty much when x is 3, y is 2. When x is 3, y is 2. If you've done it right, you should be able to see a nice straight line. And then you pretty much draw a line that goes all the way through that and all the way through that. You draw your arrowheads and you get yourself full marks for that. And again, when x is 0, y is 2. When x is 0, y is 2. When x is 1, y is 4. X is 1, y is 4. X is 2, y is 6. X is 3, y is 8. And you draw a line like that. Okay. A key point, I mean, we haven't done gradients yet, but you guys probably remember this maybe from last year. This was written as y is equal to mx plus b. M stands for gradient. And can you see that the gradient is positive? And if you remember, positive gradients are sloped to the right. I just want to say that since we're here, and you might as well start seeing. So can you see it's sloped to the right, so it's positive gradient, which makes sense. So if you somehow draw it this way, slope to the left, you know straight away it's wrong. But anyways, I don't see anyone else making those mistakes. Okay, complete each table of values and then graph the equation on the number plane. Question 2. X equals 2. Oh, okay, well, that means the x value, no matter what the y value is, is always going to be what?
2.
2. And obviously, how do you draw that? Well, if you have to draw x equals 2, there's 2, and then 2, x is 2, y is 0, which is right there. X is 2, y is 1, right there. X is 2, y is 2, right there. X is 2, y is 3. And obviously, we can see, I didn't draw a very straight line, but I think we get that. The trick to these is if it's just x equals, it's a vertical line. I know your head might say x is this way, horizontal. So therefore x equals 2, a lot of students tend to draw it this way, horizontally. It's wrong, it's the other way around. X equals 2, it's a vertical line, because x is always 2 and just y is changing. Whereas when I say y equals to 3, y equals to 3 would be this way, horizontal. So can you see the x values are changing, but the y value is always 3.
Yeah.
So this one's a horizontal. Yeah. Y equals to x. Y equals to x is x equals 0. So therefore y equals 0. When x is 1, y equals to 1. X is 2, y equals 2. X is 3, y equals 3. And I think we can tell just from that that is just going up like this. And so on. Arrowheads and just y equals x, and it just passes through the 0. Okay, and then, then you can draw up your own numbers. You can pick your own numbers. I recommend picking a few negatives. So my table would probably have an extra one here. Go from at least -2 to +2. I think that way you get some negative numbers, you get some positive numbers, you've got 0, and it works a lot better. So let's do question 3. X is -2, so -2 take away 3 is -5, -1 take away 3, -4. Let me know if I'm going too fast. 2 take away 3 is -1. Same thing with this guy. X is okay, so x is -2, but then you've already got a negative, right? So the first one will be read as -2 plus 3. But I'm sure we would have used our calculators anyways. But that's +2 plus 3 is 5. +1 plus 3 is 4. 0 plus 3 is 3. And can you see it's going down by 1?
Mm-hmm.
There it is. And then then we will draw this up to the best of our ability. So let's draw the first one. We'll draw that in black. So -2, -5, -1, -4, 0, -3, 1, -2, and 2, -1. And then red. X is -2, y is 5. X is -2, y is 5. X is -1, y is 4. X is 0, y is 3. X is, yeah, you get it. And then we draw a straight line past that. Now, obviously, I can see the next question says, what are the coordinates of the point of intersection? If you've drawn it pretty accurately, I think we can see the point of intersection is right there. So, point of intersection equals x is 3, where the y value is 0. And that's a common exam question, just for that, and that. So, very likely you would get this in your prelims. Okay, any questions?
No.
Nope. All right, let's go on. Gradients. So, again, you probably remember some of this. But before we start it, if it's slope to the right, these are positive gradients. Slope to the left, these will be negative gradients. If they have no slope, so it's a horizontal line, it's called a 0 gradient. So it's got a 0, it's flat. You can walk on it and think of it like that. And if it's a vertical line, then it's undefined. undefined gradient. I mean, think of a vertical wall. You can't walk on that. So, unless you're Spider-Man, you can't walk on that. So it's undefined, 0, positive, negative. Okay, easy. State whether the gradients of the line will be positive or negative. This one, what is it?
Positive.
Positive. This one, to the left, so what would that be? Negative. Again, slope to the right. You see that? And what about this one?
Still positive.
Well, that one's still sloped to the right. Yeah, so it's still positive. Find the gradient of each line. Okay, fine. So there are two ways to find the gradient. I probably will go through the one that is allowed in standard mathematics, which is just simple rise over run. But I do want to teach you the more advanced one. Some of you might have done in your year 10 5.3 stage at a later stage. But at the moment, we'll just do it the basic rise over run. The only problem with this method, which is why I would like to teach you the more advanced method, is that every time you do your rise over run, you must check your slope. So most students memorize rise over run. I mean, we've known that since, I don't know, year 8, but we don't, I guess, memorize this little extra bit that you must do. You must check your slope. So you must check, is it slope to the left or is it slope to the right? Because that will tell you if your gradient should be positive or if it should be negative. So you've got to be careful with that. All right. Rise and run are always going to be positive, just so we know that as well. So you can't rise negatively, you can only rise positively. And run itself, you can't run negatively, you can only run positively. So that's the idea. So if you have ever negative answers for rise and run, then there's a problem there. The idea was to make a right-angled triangle, if we remember that. So there it is. How much have you risen from -2 to 3? You have risen 5. How much are you running from -2 to 1? That would be 3. Then you can see that it's sloped to the right, so it would be positive 5 on 3. M equals 5 on 3. Any questions about that?
No.
Oh, good.
Okay, next one. Again, draw or find a right angle triangle. Right, there it is. What's your rise? Well, that's 3, and that was -4. So my rise is 7. My run from -2 to 1 is 3. So my gradient is, wait, I check my slope. It's sloped to the left. So my gradient is -7/3. Okay, remember 7 and 3 can never be negative. So these numbers here must always be positive, but then because it's sloped to the left, I make it into a negative. Try that one just quickly. Try to do your rise over run. Make an answer. Okay, rise is 4. Run. Now a lot of students see that as -2. It's not, right? Your run is +2. You got to always remember your rise and run has to be positive. So from 0 to -2, it's 2. Then, because you're sloped to the right, your answer is still going to be 4/2, which just becomes 2. Okay, next one. What's my rise here? From here to here. Well, my rise is 2, not -2, 2. My run is 4. So my gradient is rise over run, but it's sloped to the left, so it's negative 2/4. That becomes negative half when we simplify. Okay. Let me know if you've got any questions. Rise, there's my triangle. My rise is 2, my run is 2. My answer is 2/2, it's sloped to the right, so my answer is 1. My rise is 3, my run is 1. Slope to the right, so rise over run is 3. My rise is 2, my run is 2, but it's sloped to the left, so my answer is negative 2/2, which is negative 1. My rise, ooh, I've got to make a triangle. Well, let's just make a triangle from there. My rise is 4, my run is 4, slope to the right, my answer is 4/4, which is 1. Same thing. My rise is 4, my run is negative 2, nope, my run is positive 2, right? We can only run positively, so 4/2, but this whole thing is sloped to the left, which is a negative, so my answer is negative 2. All right, any questions? Did I go too fast, or was that okay for everybody?
All good.
All good? All right. Okay, so then we get these. The y equals mx plus b or plus c. Doesn't really matter what letter you choose. What you've got to remember is m is your gradient. And the number that's by itself is the y-intercept. So again, m is the gradient. The number by itself is the y-intercept. The gradient is in front of the x. So just before I start any of these, what is the gradient here? What would the gradient be for that question?
2.
What number is in front of the x? 1, right? So there's an imaginary 1. So this one here will be a 1. Right? If I said negative x, what number is in front of the x again?
Negative 1.
But here, well, negative 1. So that would be the gradient. Yeah. And if I said 6 take away x, again, the gradient is not 6. The gradient is what's in front of the x. So the gradient would be negative 1. And that's how you've got to look at it. It's always about remembering gradients in front of the x. The y-intercept is the number that's itself, that doesn't have an x. Okay.
So in that one,
That's how
the
it
6 would be the y-intercept.
Some examples. Yeah, correct. So gradient, obviously the gradient is 2, the y-intercept is 7, gradient is 3, y-intercept is 1, positive 1, so just 1. Gradient is 7, y-intercept is, well, there is no y-intercept, so it's 0. You have to write 0, you can't just skip it. Gradient is 4, y-intercept is negative 3, not positive 3. You can't just write 3. That's wrong. Negative 3. Your gradient, well, what's in front of the x? Half. Y-intercept is 6. What's the gradient? 1 in front of the x. What's the y-intercept? 4. Gradient, again, the gradient is negative 3. What is the y-intercept, the number that's on its own? 8. What is the gradient? -1, right? Imaginary 1 there. What is the y-intercept? All of that. -5. What is the gradient? Well, the gradient is not 11. The gradient is what's in front of the x. So in front of the x is -2. And then what's the y-intercept? Well, it's +11. So just 11. Not -11, be careful. It's not what's in front of it, which is -2 for gradient, and y-intercept is +11. Okay. Find the y-intercept and gradient, and then hence sketch a graph of each one. So we're going to just do the y-intercept and gradient first, and then we'll come back to sketching. So gradient equals 3, y-intercept equals 2. Gradient equals 2, y-intercept equals -1. Gradient equals 3. Y-intercept equals -5. Gradient for this one equals to 1, right, in front of the x. Y-intercept equals 0. Gradient equals what's in front of the x again? -2. Y-intercept equals 1. Gradient equals half. Y-intercept equals +4. To sketch, I just want to have a quick look at our next one. To sketch, I would like us to learn to find the x-intercept as well, unless you want to just do it by a table of values. So, I mean, what should I do? Maybe for today's lesson, I'll do it through a table of values since we've done that. Look, I'm only going to do one of them. I'll do E, and the way you would sketch it, I mean, you know the y-intercept is 1, so that's great. But you don't really, I mean, you know the gradient, but that doesn't really help us for the time being. So maybe what you want to do from that is create a table of values like we've done with the first questions. -2, -1, 0, 1, and 2. Sub in x equals -2 into that. That becomes +4 plus 1 is 5. That becomes +2 plus 1 is 3. 1, and what -2 does, it decreases the y value by 2. It's technically what it's doing. So 0, x is 0, y is 1. X is -1, y is 3. X is -2, y is 5. X is 1, y is -1. And x is 2, y is -3. And there it is. So that's probably the best way to sketch for now. And it will never fail you, ever, even in year 12. So this is like a fail-safe method, table of values. But I would like to teach you, again, the more advanced way again. Maybe another lesson. So that should be fairly easy to complete. All right. Next one. So I think now we start with the actual applications of, you know, the gradient and y-intercept into actual models and real-life problems, right? Yes. Cool. And then we look at that, and then indirect. Yeah, no problems. Okay. Independent and dependent variables. So let's have a look. Consider this equation. C is equal to 5n plus 3. When drawing up a table of values, for which variable, c or n, do we choose different values? So pretty much what it's trying to say is which one is your x and which one is your y. Because that's how you've got to see this. You still got to see it as like exactly the same as this. So what letter are we going to choose the different values for? What do we think?
N?
C or for N? N is correct. So usually when you had your table of values, it looked like this, and X was on top, Y was on the bottom, and the equation you would have had would have been something like this. So X would have been the numbers or the values that we were changing, you know, -1, 0, 1, and 2. And then for those X's, we were finding Y's, right? So when drawing up a table of values for which variable, C or N, do we choose different values? It is for N. So which is the independent variable? Well, because we're choosing different values for this, we're choosing it. N becomes the independent variable. So the X is independent. Which variable depends on the independent variable? Obviously, which letter here depended on the, on the X? It was the Y value. So which variable depends on the independent value or variable? It would be the C, right? The C depends on the N. As N changes, C changes. But C doesn't just change out of thin air. C only changes as N changes. So which is the dependent variable? Your dependent variable is always going to be your Y values or the left-hand side, or in this case, it's C. So C, as N changes, C changes. So N, again, N is your independent and C is your dependent. C depends on N. Okay, does that make sense? Is that clear?
Yep.
All right, draw up a table of values, you get it. For N being greater than 0, so saying don't choose X is -1. All right, not a problem. There's N, there's C, 0, 1, 2, 3, 4. When N is 0, you're going to get 3 for cost. When N is 1, you get 5 plus 3, which is 8. And like I told you before, if you can start realizing what your gradient's doing, so your gradient of 5, it's making your C here go up by 5. So 3 plus 5 is 8. 8 plus 5 is 13. 13 plus 5 is 18. 18 plus 5 is 23. And then, of course, draw it up. You really had to. Oh yeah, as you can see, they haven't labeled anything because we want to see that you understand this is your X, this is your Y. And don't really overthink it. This is usually being your X, this is usually being your Y. N is 0, 1, 2, 3, 4. When it's 0, it's at 3. When it's at 1, it's at, we're not going to be able to fit this in. So it's not going to be like that. It's going to go up by probably 5, 10, 15, 20, 25. 0, it's at 3, so let's just say there. 1 is at 8, there. 2 is at 13, there. 3 is at 18, and 4 is at 23. All right. And then graph it, we just did. If you don't write N and C, you will not get full marks. If you don't label here, you will not get full marks either. So just be pretty strict with yourself. Get used to that. Just like you would have learned back in year 7 to write this is X, this is Y. Pretty much the same thing's happening again, but because we're using different letters, you've got to again label as N and C. I have a read of question 2. Determine which is the dependent and which is the independent variable. All right, remember, independent must be your X. Your dependent must be your Y. Your Y depends on your X. Independent must be the K. Dependent is P. Independent is T. And dependent is X. X depends on T. As t changes, x changes. And you do it all again. So look, complete e-table values and graphs, remembering to correctly label the axes. So this is what letter? This would be Q, this would be P, 0 times 2 plus 4, 2 times 1 plus 4, 2 times 2 plus 4, 3 times 2 plus 4. And then of course, Q and P. 0, 1, 2, 3, 2, 4, 6, 8, 10. X is 0, y is 4, x is 1, y is 6. I think we get this. 3 is 12. And voila. Well, you don't need to even draw your arrows starting from here because this is starting from 0 anyways. All right, and then you guys can, I'm sure, finish this bit up if you need to. All right, the reason why you needed to know that is because we're going to apply this into like finding profits, cost, distance, maybe speed, time, and so on. And to be able to graph these, you're going to understand, in fact, all of these, except profit, are going to be positive. Profit can be negative. Cost, it's just negatively sloped, but it will still be positive. But profit can be negative depending if you're losing money. But otherwise, all of these are positives, and that's why it's starting from like 0, and they're usually drawn like that. Okay. So let's have a look at this particular application. I feel like it's looking easy, but again, will be in your exam because obviously it's worded problems and more applied. Elizabeth drew the following graph to give the weekly cost of running her car. So distance in kilometers, 100, 200, 300, 400, and the cost. So if she hasn't gone anywhere, it automatically costs her $10. Why does it cost her $10? Does anyone have any idea of why it would cost her $10 regardless if she hasn't driven anywhere? What would the reason for that be? Think about it. Something that we did last week. Why would it cost her still $10 regardless if she hasn't even driven the car? Take a guess. Any ideas? Well, she has to still pay for insurance. She still has to pay for rego. She still has to, what else do I mean? Insurance, rego. That's about it, really. If she hasn't driven it, she wouldn't need to pay for like petrol or anything. But that cost is fixed because regardless, to have the car, you'll still need to pay for your registration and insurances. And that's what that would be. Just so you're aware of it. It's really important that you understand to interpret these like that because it is real life. And you got to see it like that. What is Elizabeth's weekly cost if she travels 400 kilometers? So go up. $30. One week, Elizabeth calculates her weekly cost to be $37.50. How many kilometers did she travel that week? Halfway. $37.50. Go down. Here. These are going up by 450, 500, 550. So she would have traveled 550 kilometers. Right here. What is the cost if Elizabeth does not travel at all? Well, I just spoke about that, didn't I? See how I kind of pretty much knew that was the question coming up? It is really important that we understand this is a fixed cost. It is a cost that will always occur and that you will incur regardless of, I guess, if you're using it or if you're making any sales, if it was a different situation. So $10. why is this cost not 0? Well, again, we already spoke about that, right? You have to pay for rego, insurances, etc. So just to have the car, it costs you every week $10 for your registration, your insurances, whatever else that you need to pay regardless of if you're driving or not. Maybe even interest, actually. There you go. There might be interest attached to the car because you had to borrow money.
Do you have to name like all the possible reasons, or like is etc. like okay?
Yeah, that's okay.
Right.
The rego and insurance is the ones that we're looking for. Interest is just for you guys, since we've done a little bit of interest work. I thought, why not see it like that as well? Because you could have borrowed money for the car, and that would be a fixed cost that you have to include. Even if you're not using it, you still have to pay back the loan, right?
Yeah.
Okay, a truck will deliver fuel for $1.15 per litre plus $100 delivery charge. So $1.15 per litre plus $100 delivery charge. Okay. Now, I want to see if we can actually get the equation out for this, because if we can, then you are pretty much the top 1% of the state. Are you able to get me the linear equation for this? Now, we'll label this one C, we'll label this one L. So it's definitely going to be C equals something L, and then, you know, something. I'm not going to say what. Anyone want to take a guess? C equals something L plus or minus something else. And remember, to find an equation, it's going to look like this. Take a guess. It might be right. A truck would deliver fuel for $1.15 per litre plus $100 delivery charge. So
Would
cost,
it be
yeah,
$1.15 L plus 100?
yeah, right. Again, think about it. If you didn't get any fuel, so L was 0, well, they'll still cost you $100 for just coming out. Which would make sense. See, C equals to $100. But if you decide to buy 1 litre, well, that will cost you $1.15 times 1 plus another $100. You bought 10 litres, well, it'll be $1.15 times 10 plus $100 for the delivery fee.
Yeah.
And you've got to always see it like that. It's a linear equation, so don't overthink it. This is a fixed, that's how I like to think about it. That's a fixed cost, and your fixed cost is always going to be your y-intercept. It's always going to be by itself because it's irrespective of what's happening. That's your fixed cost. This is your variable cost. It varies. As you buy more and more liters, the cost goes up and up and up. So, cool. Where are we? Okay, here we are. Total cost. Okay, well, now that we know the equation, I mean, we could find the total cost pretty easily. It's just going to be $1.15 times 500 plus 100. So the first one, I've got my calculator, $1.15 times 500 plus 100 equals 675. Next one, if it was $1,000, $1.15 times 1,000 plus 100, $12.50. Next one, if you bought 1,500 liters, it would be $18.25. And of course, if you bought 2,000, it will be 2,400. Draw a graph to show the cost for amounts of fuel up to 2,000 liters. Well, you don't need to go to negative because you know you're not going to have any negative values. You might as well just draw these L-shaped ones. Your first one's 500, then 1,000, then 1,500, then 2,000. You've got to label it L. This is C, and then I mean, I think we get it. 675, 1250, really bad. But if you just draw it like that, you'll get 4 marks for that. So you don't exactly need to go ahead and plot, 100, 200, 300, 600. It doesn't work like that. So that's all we want to see. That you know that at 1825, at 1500 liters, it will cost you $1,825, and at 2000 liters, it will cost you $2,400. And you would have to write actually not just C, because you see how I didn't write any dollar signs or anything here. I would have to write C and an open bracket in dollars, so I know that I'm reading that as dollars. And same thing with this. I'll have to write, well, I've already written L for liters, but in L, maybe you want to write liters. You wouldn't lose a mark necessarily for this one because you've written L, but you would lose it for C here. Okay. Dale pays $2,170 for a fuel. Use the graph to find the amount of fuel he received. Yeah, good luck with that. That's never going to happen unless you had a grid papered one. So in your exam, if they give you a grid paper and you have to draw it pretty much precise, then you might be able to, estimate where it is. Otherwise, in our version, there's no way we're going to get it out. So we're going to do it algebraically. All right, where does 2170 go? I've got to find L. So where would 2170 go in my little equation here? Well, pays, well, that's C, isn't it? So 2170 equals 1.15 L plus 100, and then we just solve for L. Your first step is you subtract 100, so minus 100 and minus 100. That becomes 2070, and then of course divide by this. I think you guys can see why I emphasized algebra for so much the last term, because I know it's in every single topic. 1800 liters is your answer. The amount of fuel you received would have been 1800. Any questions about that one? All right. Let's have a look at another one. Have a quick read of this and I'll be right back. All right, Andrew receives a fixed amount of pocket money each week. In addition, if Andrew, to help his mother, she gives him an extra amount per hour for the time worked. Well, I think we already understand, there's the variable and there's a fixed cost. The graph shows the amount of money Andrew might receive in pocket money each week. What is the intercept on the vertical axis? Vertical, the intercept is 5. What does the intercept on the vertical axis represent? The fixed amount of pocket money each week. Fixed amount of pocket money received each week, right? Received each week. You understand that by now? You don't work anything, you get $5. What is the gradient of this line? Okay, well, again, to find gradient, what do we have to use? Rise over run. So to use rise over run, I need a triangle. I don't know, let's say I use that. Yeah, there's a right angle triangle. What's my rise from 5 to 20? 5 to 20. My rise is 15. What's my run from 0 to 3? 3. So my gradient equals 15 over 3, which is 5. Again, it's sloped to the right. It is sloped to the right, so it's positive. What does the gradient represent? Good question. Anyone know what the gradient represents? Okay. The gradient, the fact that you got 5 there, well, I mean, look what's happening. Maybe you might be able to tell me the answer if I do it like this for you. Watch. All right. He worked nothing. He got $5. He works 1 hour. He gets $10. He works 2 hours. He made $15. He works 3 hours. He made $20. 4. He made 25. What's that going up by? Going up by 5, right? So what does the gradient represent? The gradient represents
how much
hourly,
extra money he gets over.
Yeah, that's it. Or I would call it hourly rate.
Oh yeah.
Or extra work. Let's say that. But I think we're looking for rate. That's the big word. So you can't just say, or even if you just said, what does the gradient represent? What's his name again? Andrew. Andrew makes $5 per hour. You wrote that, you would still get the full marks. So that's what we want to say. That Andrew makes an extra, let me write extra here, $5 per hour. This means I can earn as much money as I want. Well, can briefly comment on Andrew's statement. Considering the limitations of this model. Okay. What's the problem with that statement? There is only so many hours in a day that you can work. What is the limitation? The maximum is 24 hours a day. Possible? Not really. Make sense?
Yeah.
And that's perfect. If you were to write it even the way I've written it, it makes sense to us. We understand that you understand what you're saying, and you get the idea, which is the fact that it can't go on forever. It will stop at 24 hours, but is that even possible? So that's a limitation. Well, not really possible to work 24 hours. So can he earn as much money as he wants? Not really. Okay. It's better than no in this case. Okay, because it's possible, I guess. It's very, very, very improbable. So you can't say it's impossible. I mean, if this boy wanted to make as much money as he wanted, he doesn't want to sleep for the rest of his life. He could just work for 24 hours until he burns himself out. But so you can't say it's impossible. You just got to be careful with that. You got to say it's improbable if you're ever going to use a word. So the probability of it is very low, but you can't say it's a definite no. Okay, very good. Let's go again. Have a read first, so you understand the context, and keep in mind something like already straight away, you know, a few things got to, you know, a few things have to ring. This was positively sloped. Got to keep an eye on that stuff. Oh, whoa, why is it sloped like that? Okay, I've got to keep that in mind. It's negatively sloped. You know, so I'm losing stuff. You got to keep that in mind. But anyways, continue reading. It should make sense. Okay. Melissa intends to ride a bicycle from Baxton to Clare to raise money for the local hospital. The graph shows her expected distance from Clare in kilometers over time. I think it's from Baxton. Right? Yeah, I think I just did a mistake there. It should be from Baxton, but it doesn't matter. What is the intercept on the vertical axis? 90 kilometers, pretty much, right? That means from Baxton to get to Clare, you now know that that distance is 90 kilometers. What information does this intercept tell us? So you can't just say, I don't know, it's a fixed cost of 90. There's a different context. This context is about a bicycle, this Melissa who's riding a bicycle from Baxton to Clare. So what information does this tell us? That the distance from Baxton to Clare is 90 kilometers, right? And as the time goes on, eventually the distance becomes 0. Why? Because she actually arrives there. So you've got to be able to interpret these graphs, and that's probably the hardest bit of linear relationships. It's the interpretations, because they're so open-ended as well. What is the gradient of the line? Again, just pick a right angle triangle. I'm going to start it from here and go to here. My rise, 30 to 60 is 30. My run, 2 to 4 is 2. Slope to the left, please be careful with that. So it's negative, rise over run, which is negative 15. What information does the gradient tell us? Well, bit of a tricky one. The gradient is rise over run. Yeah, but what is your rise in terms of? Your rise is in terms of distance. So you've got distance over run. What's your run in terms of? Does this ring a bell? Distance over time.
Oh, yeah.
What is that equal to? Speed. So this here is 15. The information that it's telling us is the speed that she's traveling per hour. So she's going 15 kilometers per hour. Every hour, look, there you go. She lost 15 kilometers. 90, she's down to 75. From 75 in the next hour, she's down to 60 k's left. From 60 kilometers, another hour, she's down to 45 kilometers. Another hour, she's down to 30. Another hour, she's down to 15. Another hour, she actually gets there. So that was a tricky one. And there's not many of these tricky ones. There's only like, you know, 1 or 2, because there's only so many times you can get fooled by speed and distance over time. So speed is equal to distance over time. So what does the gradient tell us? Speed per hour, which means 15 kilometers per hour. What is the equation of the line? Does that someone want to give it a go? Equation of the line, I can give you, it's D equals. You already know the gradient, you know the y-intercept. Dahlia, do you want to try it?
Um,
D equals, and then what's your gradient?
Would
Your gradient.
time
First say you got to do gradient because what's the formula for a straight line? What's the equation of a line? Y equals what?
y mx plus b.
Yeah, so you first have to say your m. So what's your gradient? D equals?
Would that be t?
No, your gradient is here.
Oh.
What is the gradient of the line?
Oh, jokes. -15.
Negative 15.
And then x, and
letter,
then plus t.
plus,
Oh no.
no, x is your letter. No, that's your variable. T plus your y-intercept. What's your y-intercept now? Where is it intercepting the y-axis?
90.
90. And that would be the equation of that one. Let's do another one like that. Let me see if I can find you another one. Did we do this one? No. Okay. This one here. Let's try to find the equation of this line. Well, I know that we'll just label this as P for pocket money and T for time. It's going to be P equals, I need a gradient. I know it's T plus, and I know the fixed value is 5. What was my gradient? Well, we worked out my gradient using run, which is 5. So the answer is P equals 5T plus 5.
Oh, yeah.
Let's do another one. Yeah, look, I think we had one up here. Yeah, this one here. So again, C and then D. So C equals something D plus fixed. Your fixed cost is $10. What's your gradient? Well, the gradient I think we worked out. Did we work out gradient here? Oh, it doesn't look like it. All right. Well, we can work out gradient. We just need a right angle triangle. So let's pick this one to this one. What's my rise? My rise from 25 and 15 is 10. My run from 100 to 300 is 200. So your gradient slope to the right. So the answer for your gradient is it's 10 rise
Over 200.
200. D plus 10, and then obviously that simplifies to 1 over 20, but whatever. And that's it. So no matter what D I sub in now, I can work out my cost straight away using this function.
Yeah. I get that now.
Okay. Conversion graphs. They're okay. I don't think they're too complicated. Have a read of question 1. I think you guys can probably already see some of the answers straight away. Have a read, and we'll start. Okay. A student obtains 120 marks out of 150. Well, 120 out of 150, then he usually got 80%. Yeah, that's how you read them. A 50% mark, how many marks out of 150 must a student get? If it's 50%, that means you obviously would have got 75. A distinction mark is 80% or better. How many marks do you need for that? 80%, well, we already know that's 120. Above, but just go across 120. A student has been demoted to a lower class if he gets 30 marks or less. 30 marks or less, so that's 20%. Easy, right? Let's have a look at currency conversions. When Nellie was planning her overseas trip, 100 Australian dollars was worth 72 US dollars. So 100 Australian was 72, we'll go somewhere there, 72 US, all right? 100 Australian, 72 US. Use this fact and the fact that the graph goes through the origin, so it starts from here, to draw a straight line graph. Well, come on, let's join the two together, right? That's all you can do. Ugh. There you go. Okay, use the graph to answer the following questions. What was the value in US dollars of 75 Australian? 75 Australian, looks like it's 60 bucks. 60 US. What was the value in Australian dollars of US 40? That looks like midway from the way I've drawn it. So 50 AU. Any questions? Easy?
Yep.
Yeah. All right, and we do it all again. I might just leave it because it's literally the same. It just says there's, Fahrenheit and Celsius. You just put 0 degrees is 32, so you're starting from there, and then you're going to draw a line, and then you just have to use your graph to find your answers. It's not that much harder. All right. Direct variation and indirect variation. So some of you might have seen this. Oh, no indirect. What? I think they're taking that out of the syllabus. That's not fun. You probably have seen this last year. I remember Dahlia, I think, teaching it to you. Direct and indirect variation. But it looks like you only need direct variation for this year. So let's do it. And it's the last bit of linear. So we're pretty much, yeah, we're doing really well. All right, direct variation equations. It is known, all right, so direct variation, just so we understand this. We know there's a relationship between y and x, and they're directly related. Cool. We just don't know if it is related like this, so if it's y equals to 1x, if it's 2x, if it's 3x, 4x, if it's 4 on 5x, if it's 4 on 7x. We don't know the number, but we know there's a relationship between them. So we're not sure if x is like, 4/5, or as I said, 4 times y, or 3 times, or 2 times, or 1 time, or whatever. Because we don't know, we label that as another letter. Let's call it k. And the aim is to actually find k. So step 1, find k. That's going to be step 1 all the time. Once you find k, you'll have your new equation, right? Which would be like, let's call it, if k was 3, you now have your new equation, which is y equals to 3x. From that, if I tell you, hey, go find me y, given x is 10, you're just going to go, yeah, y equals 30. If I say, oh, no, actually, go find me x. If y is 3, you're going to go, okay, that's 3 divided by 3, and you can work out x. So, new equation, and then 3, I'm just going to say solve. So it's pretty easy. The hardest step is the very first one, find k. And the reason why I've got to write this 1, 2, 3, it's not always going to be broken down for you like the way, question 1 and question 2 is. It might just go and give you the question and then go into part B. Hence find this, or just find the value of y. You have to remember your step 1 is to always find k. If you can drill that into your memory, then these are pretty straightforward questions for those who are really strong at algebra. So let's have a read. It is known that y varies directly with x. That just means varies directly with x straight away. It just means it is y equals kx. When x equals 20, then y equals to 4. First, find the value of k. Well, you already know y equals to 4, x equals 20. Obviously, what letter are you going to find? K. 4 divided by 20 equals 1 on 5, which is 0.2. as a decimal if you wanted it like that. Any questions there? Because that's a really important step. We all understand what I've done there? You're always going to be given this fact. When x is 20, y is 4, and you've got to sub it in to find k. Otherwise, how else would you find k, right? So you've got to get rid of x and y. Okay, and then pretty much step 2, you have your new equation. Well, your new equation is this. Step 3, just solve. Solve is find y when x is 12. Well, I mean, come on. Seriously, some of these questions shouldn't even be in like year 11 or 12, right? But they are 2.4. There it is. Done. Question 2. Question 2. The electrical current in amps in a circuit varies directly with the voltage. Whoa, it looks so complicated, but all it means is just this. Y equals Kx. Or if you want to use the words, voltage and amp. So V equals Ka. When 21 volts are applied, the current is 7 amps. Okay, so 21 equals K times 7. K equals 21 divided by 7, 3. Hence, what is the current in amps when 15 volts are applied? Well, we know our new equation. There it is, y equals to 3x. Sorry, not y. It doesn't matter if you chose y. It's the same stuff, right? But anyways, v equals to 3a. V is 15. And how would you work out amps? You're going to divide by 3. Now, how are we finding that? Girls, are you all good with that so far?
Yep.
Yeah.
Brilliant. I might skip that one. Looks the same. That looks the same. That's the same. Yeah, they're all the same. So no, I'll just do B. Question 5. Sorry. Hooke's law states that the distance, blah 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 blah. You get the idea. Like, who cares about all that, right? All you care about is the distance is 25. The mass is 4. So D equals to K times M. Distance is 25. K times 4. So therefore K equals to 25 divided by 4. Plug that into your calculator and you shall get it as a decimal, 6.25. Your new equation is D equals 6.25 M. And then what is the distance when the mass is 5.2? Times 5.2. Distance is 32.5 centimeters. All right. Easy stuff. Your direct variation graphs, the good news, they're exactly the same as your y equals mx plus b because they're all just straight lines. The only difference is that for pretty much all of these graphs, you won't have the b. So they're even easier. They're just going to be straight lines like this, starting from the origin all the time. But you'll know that because you're gonna draw it and you realize there's no y step. Your y step's always at 0. It is known that y varies directly with x. When x equals 5, y equals 30. See how it says just draw the graph? You're not meant to do that. You're meant to always remember step 1 for anything that varies directly is to find k. So y equals to kx. Y is 30. K times x is 5. So k equals to 6. Cool. And then draw the graph now. So we now know the equation is y equals 6x. Starts at 0. When x is 1, y is 6. When x is 2, 6 times 2 is 12. 3, 18. 4, 24. 5. 5 times 6 is 30. And we get the idea. Find the gradient you just did. That is the gradient. So the k you're finding is the gradient, right? Because mx plus b and whatever the so gradient equals 6. Write the equation connecting x and y. We just did. So if you follow my technique, those step 1, 2, 3, you're pretty much answering all the questions they'll ever ask you for those styles of questions. Okay. And we'll just move on and try this. I'll try question 2. A car is traveling at a constant speed. It travels 80 meters in 5 seconds. 80 meters in 5 seconds. Draw the graph in distance against time. So distance time. Distance equals k times time. There's time, so that's your x. There's your y value, so d. Travels 80 meters. K times 5. Bring the 5 over. I think it becomes 16, right? 80 divided by 5 is 16. Yep. So your new equation is 16 times t, and then again 16 times 0 is 0, 16 times 1 is 16, 16 times 2 is 32, somewhere there, 16 times 3 is 48, and so on and so on and so on. And you pretty much draw your line eventually. What distance would the car travel in 3 seconds? 16 times 3. How many seconds would it take the car to travel 120 meters? You know, something like whatever we would have had, I don't know, but let's work it out exactly. 120. Find time, you just divide it. 120 divided by 16. Oh, not bad. 7.5. So it would have been something here. If I had kept on properly. Okay. Seconds. All right, brilliant. Now it's up to you guys. Do you want to move on to time and look at time and then next week spend, like I said, revision? Or do we want to, spend, like it says, 7 minutes to do a quick little topic test and revise some of this right now before we move on to the time work? Start a new topic or just do a bit of revision for about 10 minutes?
Like a revision on linear or like everything?
Yeah. No, linear.
Oh no, I think I'm alright.
Yeah.
Okay.
Yeah.
Now everything we're going to do next week.
Okay.
Which I think would be good. Just to go through a bit of pretty much all of this stuff. Okay, then time it is. Oh, this one's going to be annoying. This was part of year 12. It got brought down to year 11. Beginning's going to be okay. All right. All right. New heading. Working with time. Okay. Just to make sure that you guys can do this all in your calculator, to put these into our calculator and add these, we use the bubble button. So the way you would write it in your calculator, I know you probably can see the answer already. I just want to get used to doing the calculator so when we get to the harder questions, we're still able to use it. 2 hours, and don't get me wrong, I mean, you can use your normal counting technique. So you can do 2 + 1, 40 + 16, whatever techniques you know, you can still do, obviously. But for some of them, we're just going to do it with our calculator to make sure we know how to use it. So 2 hours and 40 minutes, you would press 2 and then the bubble button. We're going to call it bubble button. And then you would put 40 and then again. So 40 and then again. Plus, you would write 1 bubble, 16 bubble. Okay, just go ahead and quickly try that so you can understand how it works. And then once you've done that, you should see it saying 3 hours and 56 minutes, which means 3 hours and 56 minutes. Please go ahead and just quickly do B, C, and so do all question 1 and question 2. Write them down. Okay, so let's do these. I'm just going to add them normally. 5, 30, 50, 6 hours this should be. This one's going to be 7, 8, 50, so 9 hours and 15 minutes. So let me know if it's wrong. 320, this should be 2 hours and 5 minutes. This one should be 7 hours and 15. And then this one here, this is where it works really nicely. So 5 hours, 20 minutes, you don't even need to think much. 20 hours, 35 minutes. You should just get 2 hours and 45 minutes. Any questions there?
Nope.
Okay. What is the time difference? Again, for these question 3, for question 3, you can probably tell that, you know, the first one's easy, whatever. You could just write 1 hour and 20 minutes. But the way I would like it done, in case you wanted to use your calculator for maybe some of the harder ones, let's think about this. What could you use? Yep. So you should be able to use the bubble button. So you'll go 4, take away 2 hours and 40 minutes. Yeah. So go ahead and try that. Really try that. 4, take away 2 hours and 40 minutes on your calculator. And then the first thing I got was 1.3333. Then you press the bubble button again. Please confirm you actually can see 1 hour and 20 minutes on your calculator. Are we having problems with that?
No, all good.
All good. Okay. B, 8:35 a.m. to midday. Okay, for that one, you should still be able to do 12 take away 8:35. So 8 degrees, 35 minutes. So try that, and again, confirm you're able to get 3 hours and 25 minutes. Let me know so I can move on once you guys have done that. Okay. Any questions about that?
No.
Right, C. Okay, this one here. See how it says PM and AM? So you can't just go and subtract it, right? Because that would be obviously your calculator would assume that would be 10 AM if you're going to go ahead and subtract the two. So the trick for this, okay, the trick for this would be to keep this into that and that and that and that and that and that. And just make sure. I mean, again, I know you can just count and you can probably tell the answer straight away. It's not but that's not the problem. How am I going to do this one? PM and AM. If I make this into 24-hour time, so that would be the idea. If I make this 24-hour time, 24 hours, that would be 2200, 2205. Take away 3, 4, 5, 33, 45, 33, 45. AM to PM, AM to PM. Okay, obviously it was 3:45 AM to PM, and that would be that answer. For PM to AM, you'll get that answer and subtract 12 from it, right? So it'll be 2205, take away 345, take away 1200 hours. Maybe that's too basic for me to even use via the calculator. Let me think of a different way. 10 to 5 p.m. We have to 12 hours, 10 to 5 a.m. Dodgy. 7 a.m. to, I'm sorry, 7 p.m. to 8 a.m. I don't know how to make this any easier than just counting. I think you can just, all you've got to do is just count. I'm trying to think of another version, but I can't. So 11, 12, so that what's that, 5 hours and 40 minutes? There has to be a different way though. I mean, I know that's easy. I didn't mean that easy way. I meant I've got to show you a way to do it via your calculator. What am I missing? I'm pretty sure I should have done it in 24 hours time. 24 hours, 22, let's try it again. 2205. Minus, let's have a look. No, 3 hours 45 minutes minus yeah, I've got nothing to make this any easier. But we're okay with that, right? Just the way I've done it. Adding 5 hours and adding another 40 minutes. That just makes a lot of sense. Okay, add 3 hours, 45 minutes to these times. Well, that should be fairly easy. That one you definitely can use your calculator button for. So just add 3 hours, 45 minutes. What time is it? 2 hours and 20 minutes before midday. Again, you should be able to just go, yep, midday, 12, take away 2 hours and 20 minutes. Right? So 12 take away 2 hours, 20 minutes gives you 9 hours and 40. So 9:40 a.m. Convert to 24-hour time. The way we convert to 24-hour time is if it's PM, you just add 12 to the first number. So that becomes 15:35. If it's 10:45 PM, just add 12 and that becomes 22:45. Oh, that's what I was doing. I wrote 20 here and I was trying to do that in my calculator for you guys. 22:05, take away 3. No, I was doing that. Don't worry. 22:45. I don't want to confuse myself. This one, if it's AM already, then it's 11:28. Are we all okay with that? Do we know our 24-hour time? Are we comfortable with 24-hour time?
Yeah.
Okay, cool. PM, again, it says 1840. The way we do it is you just take away 12 from the hours. So 18 take away 12 becomes 6:40 PM. Take away 12 becomes 10:55 PM. Well, it's already 10:52 AM, so that's just 10:52 AM. Can't be bothered doing question 8. It's too straightforward. It's just about he goes here, he allows 40 minutes. How long will it take for him to get there, and blah blah blah. So that's too easy. We're just going to move on. Have a look. Timetables. Use the bus timetable to answer the following questions. Okay, Monday to Friday, university. Starts at 11:10. You get to Wattle Street at 12:25. And then obviously comes, that it takes 11 minutes to get to this destination, 8 minutes to get to this destination, 9 minutes to get to this destination, and so on and so on and so on. And you can tell the bus comes every 20 minutes. So 11:10, 11:30, 11:50. How long does a journey take from Blandford Station to Pratley Shops take to here? So how long does it take from here to here? Can someone find an answer for that? So from here to here. Let's see if you guys can get this one right. Try to use your bubble button. This makes life a little bit easier. So please, when you got an answer, just let me know. Cara, do you have an answer? No? Dahlia?
Not yet.
Can you guys hear me?
Wait, can you hear me?
Ah. Do we have an answer for this yet? Still trying it? I'm confused. Can we hear me, or what's the situation? I'm not sure.
Yeah, I can hear you.
Is the connection gone? Hello?
Can you hear me?
Yeah, I can hear you. Okay, fair enough. What about Karina? Can you hear me?
Yeah, can you hear me?
Yeah, okay. So, have we been able to answer this question yet?
I'm just trying to work it out.
Just plug it into your calculator, yeah? So
5 minutes.
45 minutes. Plug that straight into your calculator. Do you know what you're doing, Karina? Do you know which bubble button we're talking about here?
Yeah, is the one you like the sine, cos, and tan?
Yep. All right.
Is it that one?
Yeah, it's underneath the square root. Yeah.
Yeah.
So just put it in exactly like that, and you should get 45 minutes. Okay. Heidi planned to catch the 11:10 bus from the university, but it was minutes. If it did not make any time up, what time did it arrive at the Wattle Street terminus? Did not make any time up. So that means it was always 6 minutes late. Well, it would have arrived at 12:25 plus 6 minutes late, which is 12:31. If the present time is 11:40, how many buses can Laura catch from West Ridge Shops so that she can be at Cardiff Civic Centre by 12:30? Well, if she's at West Ridge Shops, it's 11:40 right now, then she can catch this one or this one. The problem is she needs to get there before 12:30, so she can't really catch this one because she'll get there at 12:36. So there's only one bus from 11:41 to 12:20 till 12:16 to arrive. Okay. Let's go to the next one. Have a read of this. Question 2. I'll start answering the question, but first have a read. Maybe get some of the answers out. Give you a few minutes to see if you can work it out. Okay. What time does the 1421 from Davison arrive in Svendsen? Davison to Svendsen. 1421, which is this one. What time does it arrive? 16:33. In other words, 4:33 p.m. How long does the train leaving Glenfield at 13:18 take to arrive at Williamson? So 15:58, and it was 13:18. So I just want to try this one more time and see. We should be able to do it this way. And that is exactly right. So you should be able to plug this into your calculator using your bubble button again. So it should take 2 hours and 40 minutes. Unless we can just say 15 take away 13 is 2, 58 take away 18 is 40. Like I'm losing some of you. Okay.
You're breaking out like a little bit. That's the weird.
I'm breaking up.
Yeah. Like it would freeze for a bit, but then
Little
it's
bit.
like, yeah, it come back.
Okay, hold on. All right, hold on. And it just happened, right?
Yeah.
Mine's been
sec.
happening
I
throughout.
know exactly what it is. Okay, what about now? No, still
Yeah.
bad?
It's alright.
Yeah, it's bad. I can still hear you.
Right,
I
hold
think
on.
it's just my Wi-Fi stopping up.
Okay, I'll make it stronger in a second. Let me just answer this one. Selma's train leaves at Davison at 14:59. And see how we go. So Selma's train leaves at Davison, yep, at 14:59. That one there. She wants to get off the train at the third station the train stops at. So 1, 2, 3. At what station will she get off the train? Westmead. All right. Phil arrives at Svensson. Phil arrives at Svensson on time at 16:51. What time did the train leave Nellybrook? 15:16. Or in other words, 3:16 p.m. Davia, can you hear me better now?
Yeah.
All right, 3:16 p.m.
Are these questions that would actually be in prelims?
This one, no.
I was gonna
Like,
say.
I mean,
I
not,
was like,
yeah. The one above, yeah. Like this,
Mm.
sorry, not that one. These ones, these changing converting times, yes.
yeah.
But this one here, yeah, probably not. Unless they're very lenient.
Mm.
So, actually, okay, then if it's too easy, we'll just move on. I think it's easy as well. Working with time, measuring latitude. Which points lie on the following parallels of latitude? 60 degrees north. So latitude, it's a little bit funny because a lot of students get this mixed up. Latitude, it is, I know some geography teachers teach it as flat for lat. Oops. Flat, lat. Yeah. So latitude is flat, so it's horizontal. The problem is in math, we read horizontals like this as it moving up and down. So can you see they're drawn horizontally, but the way we would read them is as they move up and down this sphere, or this obviously this Earth. So when we say latitude, it's actually north and south, whereas everyone thinks, oh, because it's flat, it's meant to be east and west. So it doesn't work like that. Latitude is north and south. Longitude, which is drawn obviously vertical, so that's it. There it is, vertical. But because as you draw these vertically, they're going to be read from left to right. These will be east and west. So just keep that in mind, and we'll make a note of that. But otherwise, the rest is easy. Which points lie on the following parallels of latitude? 60 degrees north, and you can just see it's G. 40 degrees south, you'll read M and H. And so on, right? Do I really need to continue? Are we okay with that? Or should I continue a few more?
I get that.
Yeah.
Yeah, I get that too.
Yeah, cool. All right, then we'll move on. And then I mean the same thing for this guy. So don't worry about it. The latitude, this is a bit more important. The latitudes of two places A and B are shown. So find the difference in latitude. Okay. So it's important to know if they are both north or if they're going to be different, north and south. The reason why that's important is because here, if you look at it, if you look at this beautiful earth that they've drawn up for us here, we've got this being the equator, right? 0. Now, if I said from here to here, what's the degree? You would say 15 degrees because that's 15 degrees north. If I asked you from here to here, what would you say? You would say it's also 15 degrees, right? But if I asked you from 15 degrees north to 15 degrees south, you've got to say, well, that's now 30 degrees. And that's really important. So if we're going to go from 67 degrees north to 13 degrees north, then theta, your angle, is just 67 take away 13. Do we understand that? Because it's still north.
Oh yeah.
This one here, it says 40 degrees north and 25 degrees south. So somewhere in the middle there, it should have been 0. So from 0 to here is 40 degrees. Then from 0 to 25, it's 25 degrees. So your theta is actually 40 plus 25, which is 65 degrees. And yes, of course, everybody eventually memorizes. If it's north and north or south and south, you just subtract. If it's north and south, you add. So if they're different, you just add them. Which makes sense anyways, the way I just draw it here. So imagine that's 0, that's 53 degrees, plus 17 degrees. Altogether, your angle is 70 degrees. Okay, the difference in latitude between the two places is shown. Find x. Okay, you know this is 50 degrees. You know this whole thing's 65. Anyone want to take a guess at what x should be? If that's 50, this whole angle is 65 degrees. Well, you know that's 0 somewhere there. If that's 50 and 65, any ideas what x is going to be?
That would be 15.
Degrees what? South.
Yeah.
You've got to write the south.
Okay.
Yeah, that will be 15 degrees. Good job. And then same thing with this 43. You know if that's 43, but the whole angle is 59. Again, if you assume that was 0 somewhere there, that's 43 degrees. You still got a bit left over.
And then 4 degrees north.
It would be 59 take away 43.
Oh, jerks.
16 degrees.
Yeah.
And then again, this is 90 degrees, and yeah, I think we're getting the idea. That's 0, that's 48. 90 take away, so x equals 90 take away 48, which is 42 degrees south. I make everything look easy, don't I?
Yeah.
All right, and then you just do it again, except this time it's just going to be, read this way, whatever. Boring stuff. Please don't find out between A and C. Use the diagram in question 2 to find the difference in longitude between the points A and H. Let's see. A is there. H is here. A is 30 degrees west. H is 125. So let me just write it. A is 30 degrees west and H is 125 degrees east. Anyone want to give me an answer for the difference in longitude? Let's call it theta again. Anyone want to take an educated guess at what they think the answer is for theta? The angle between this and this. Works the same way as before. 30 degrees to 0 is 30, plus 0 to 125 is 125. So altogether, the angle from here to here is 155 degrees. Does that make sense?
Yeah.
From A to C, C is 0, so that's just 30 degrees from here to here. From K and G, K again is on 0, so to G is 80 east. From 0 to 80 is just 80. Let me know if I'm going too fast. From E to G, again, E is on 0, so E to G is also 80. As you can see, it doesn't matter. I mean, maybe you guys know this from geography. It doesn't matter where you are on this. You're always going to be at 0 degrees. So it doesn't matter if you're on the northern hemisphere or if you're in the southern hemisphere. You're on the same line, on the same longitude, and so on and so on. Okay, let's do this. This will be in your exam. So this one's an exam question. The international dateline has a longitude of 180 degrees. That just means, yeah, it starts at 0 here. The international dateline's opposite, somewhere back here. But you don't need to worry about that. What is the difference in longitude between A and B? Okay, longitude. So longitude we know is east and west, not north and south. So this one's lat, this one's long. Okay, so if it's 175 east and 160 west, what is the difference between the two? So the international dateline has a longitude of 180. So you are 5 degrees away east. So imagine, so you're here somewhere. So this is 180 degrees. And it's saying you are 175 degrees east. So let's say that was 175 from there. And then you're 160 west. 160 west, all right? 175 east, this is east. And 160 west is there. How many degrees are there between the two? Can you see that's still 175 take away 160? Or you wanted to think of it like this. This is 5 degrees here and 20 degrees there. Ooh. That's 25. It's not the same as doing 175 take away 160. Fair enough. So 5 degrees this way plus 20 degrees this way to the left. So altogether 25 degrees. I'll do B a little bit slowly now. Again, look at, that's 180, somewhere there. You got 153 west, so let's just say any number there, it doesn't really matter. And you've got 142 east, so that's 142 degree east. Okay, what's the angle from 142 to 180? The angle from here to here is 180 take away 142, which is 38 degrees. What's the angle from here to here? Again, 180 take away 153 is 27 degrees. So what's the angle from A to B? 27 plus 38.
Oh, that makes sense.
Do we understand that? So that's a bit of a different one. But that's how that works. And let's try it one last time. Again, think of 180 as in the middle instead of 0 degrees. So there's 180. There's 168 east, 168 east, 148 west. Again, what's the angle from here to here? The angle is 12. Angle from here to here? 32. And then you just add them together from west to east. 32 plus 12, 44. 44 degrees. All right. How are we going for time? Oh, 5:28. All right. I think we'll leave it there then. We've got time zones and traveling, and that's it. All right. So, like I said, so next week we'll smash out the last 2 bits of time, and then we'll just do a whole, I don't know, hour and a half or so on revising everything we've done before we move on to week 3, and we'll start statistics. So
Sweet.
we're doing